Morning, guys. Morning. Has anyone seen the memory from breakfast? Guys?
This isn't just forgetting. This is what Alzheimer's disease actually feels like inside your brain. A healthy brain. Imagine your brain is one enormous city. It contains around 86 billion neurons. Let's say every building represents a neuron, every road is an axon, and cars are electrical signals carrying information. Every thought, every memory, every movement. These neurons communicate through tiny junctions called synapses. Whenever one neuron wants to send information to another, it releases chemical messages called neurotransmitters across this tiny gap. When this happens over and over again, those connections become stronger. This ability to strengthen connections is called synaptic plasticity, and it's how we learn and form memories. Meet the hippocampus. Meet one of the brain's most important memory centers. Think of it like a librarian. Today's memories arrive, names, faces, conversations, where you parked. The librarian files them away into long-term storage across the brain. The years before symptoms. Now here's something many people don't realize. Alzheimer's disease often begins 10 to 20 years before any symptoms appear. Small protein fragments called amyloid beta begin collecting outside the neurons.
Who left this here?
Scientists still debate exactly how amyloid starts the disease, but we know these proteins begin accumulating long before diagnosis. The connection between neurons become less efficient, and neuroscientists call this synaptic dysfunction, the brain's maintenance team. Normally, your brain has its own cleaning crew. These immune cells are called microglia.
Got it.
Eventually, they become overactivated, and instead of helping, they release inflammatory chemicals.
You're, helping a little too much.
Neuroscientists think chronic inflammation may contribute to further damage of synapses and neurons. Inside the neuron. Inside every neuron is an internal transport network. These microscopic tracts are called microtubules. The train carries energy, proteins, nutrients, and everything arrives at its destination. Tau proteins. Tau proteins normally stabilize these tracks. Everything looks perfect. Tau goes wrong. Then tau suddenly changes shape. In Alzheimer's disease, tau proteins become abnormally phosphorylated. Think of phosphorylation as adding tiny chemical tags. Too many tags change tau's shape. Tau lets go, tracks collapse, and tau twists. Instead of supporting the tracks, tau sticks to itself.
Well, that's not good.
Neurons begin starving. No deliveries, battery dropping. Without functioning microtubules, essential proteins and nutrients can no longer reach every part of the neuron. Eventually, the neuron can no longer function properly. The light. Messages stop arriving. Messages become slower or disappear altogether.
Hey guys, I've got today's memory. Sorry.
This is one reason people with Alzheimer's disease struggle to form new memories. Why recent memories disappear first? Because the hippocampus is one of the first brain regions affected, new memories can't be organized efficiently. That's why someone with Alzheimer's may clearly remember childhood, but forget breakfast. As Alzheimer's spreads. As the disease progresses, it spreads into other parts of the brain. Language, planning, decision-making, visual processing, recognition, navigation, emotion, each region dims. Different brain regions perform different jobs, and as more neurons die, different abilities become affected. Imagine experiencing it. Imagine knowing you know someone's name, but the pathway leading to that memory has been damaged. Imagine recognizing your own house, but not remembering how to get there. It's not giving up. This isn't laziness. This isn't not trying. The physical networks that retrieve information are becoming damaged. The brain physically changes. As neurons and synapses are lost, the brain literally loses volume. People with Alzheimer's disease don't lose their worth. They're living with one of the most complex neurodegenerative diseases us neuroscientists know. The more we understand the science, the easier it becomes to replace frustration with empathy. Understanding the brain changes how we understand people.